Hello and welcome to this Festival of Maths presentation. Today's session covers technology in A-level and further mathematics and will be presented by our trainer, Stephen Walker. The session is due to finish at 5 o'clock today. If you are having technical issues, please bear with us and we will contact you directly via private message to resolve this for you. If you are able to hear this audio and can see the slide on the screen in front of you, please click on the green tick on the right-hand side of your viewing pane. The tick is underneath the list of delegate names, and this is to help us to see that everyone's audio is working. During the course of the webinar, your microphones will be muted. All you'll need is your mouse, keyboard and headphones. There will be opportunities to ask questions throughout the course of this session. To do this, use the chat box on the right-hand side of your viewing pane. When sending your question, please be sure to select Host, Presenter and Panelists from the drop-down menu. You can type your questions at any point during the session, but please be aware that these will be addressed and at a suitable point. You might find that your question is already answered during the course of the session. I will now hand you over to our subject specialist.
Good afternoon. My name's Stephen Walker. I'm one of the subject advisors in the maths team at OCR, and I'm currently working on the redevelopment of the OCR GCE maths and further maths specifications. Prior to joining OCR back in July 2014, I was teaching secondary mathematics both in the UK and overseas, and have held head of department and pastoral responsibilities over that time. I originally studied materials engineering, but moved into education after an enjoyable 4 years as a volunteer maths and science teacher with VSA. This session is aimed to look at the use of technology in the reformed GCE maths qualifications, both in terms of what learners should be able to do in the actual examination and as part of the teaching and learning. Please feel free to type any questions that you may have at any point during the presentation. I will try to answer as many as possible throughout the session, but if time restrictions means I can't cover everything in this hour, then I will make sure that I get back to you afterwards. And a recording of the webinar will be made available, so your colleagues in your school, you'll be able to share the recording of this afterwards. I'm going to look at what changes have been done. I'll be looking at the assessments and the technology that students will be able to use, which is calculators, and then some ideas for teaching and learning. So in terms of the criteria, these are set by the JCQ, who is the Joint Council for Qualifications, where all the exam boards come together and discuss how exam sessions should run. There is also criteria that's been set by DFE, specific for maths, and I'll also look at the issue of calculators between scientific and graphical in this section. So JCQ, essentially the key thing is that the machine and the calculators cannot communicate with other machines. My apologies, let me just get rid of that. A lot of the new calculators do have USB ports, but basically that means nothing can be plugged into those USB ports. You can't have something that will make the calculator either Wi-Fi enabled or having leads connected into something else. In terms of what I'm going to be talking about today, I am going to be talking about calculators for maths and further maths. The one paper I will not be covering today due to the time constraints is the OCR Spec B MEI Further Pure with Technology paper where students would have access to computer technology or a calculator with CAS, computer algebra systems. Unfortunately, I won't be talking about that in today's session. Now, from the DFE, as part of the subject criteria for maths, the idea that students must have an iterative function. For most students, they'll be familiar with this from GCSE using the answer recall function on their calculator, but also the ability to compute summary statistics and have access to probabilities from standard statistical distributions. So for A-level maths, this is the binomial distribution, which is also in the AS, and the normal distribution, which is only in the A-level. So binomial could come up in AS and it can come up in the A-level. The normal distribution is only in the A-level maths. And there are a number of calculators with this. In further maths, there is an additional requirement that in the OCR specs that students would have the Poisson distribution, and there is also the requirement that students would be able to perform calculations with matrices. But it has to be said that the calculators that students would need for A-level maths will do all of these additional functions that are needed for further maths. So they don't need two separate calculators for maths and further maths. And it has to be said that these rules on calculators set down by the JCQ apply to all exams, so they don't need different calculators for the A-level maths compared to what they would have been using at GCSE. So for those able students that you have Key Stage 3, Key Stage 4 that are going to be progressing on to Key Stage 5 A-level maths, the sooner they start using these functions, especially the iterative function and knowing their way around the calculator, the better prepared they will be to use their calculators efficiently. Now, there's always this issue about would a learner be disadvantaged if they didn't have a graphical calculator? So I've just seen a couple of questions. In terms of the dot and cross product for vectors, I need to check that. When I pull up the calculators, we can have a quick look through the menu just to check on that. So we'll come to that, Claire, shortly. But these two calculators, the Casio FX991 EX Class Wiz and the Texas Instruments TI-30X Pro, have been used extensively by the developers when we were putting together the specification and the sample assessment material, and they'll be using these for developing the practice papers and moving into the live papers. Now obviously these are the two calculators we've been using extensively at the moment. There will be new models from different manufacturers as the new A-levels come into live, and there will be updated models from Casio and Texas in due course. And it is a clear intention in the reform that learners should be investigating families of curves and statistical graphs. This can be done on a graphical calculator, but in class it can also be done using computer-based technology. Key thing is that just simply turning up to the exam with the top calculator is no substitute for good preparation throughout the course. Oh, and thank you, David, pointing out that yes, the class whiz will evaluate the dot product for matrices. So if I start off with inside the examination, so this is limited to the use of calculators. I've taken some screenshots from emulators for both the Casio and the Texas Instruments. So hopefully you can see exactly how this can be accessed by students. So here's the image of the two calculators. As I say, there will be more coming available, but these are the two that we've been using quite widely. It is always worth considering that if every student in the class has the same calculator, that can make it a lot easier to prepare students so that you can demonstrate rather than having to think which calculator an individual student is using. These are both very good calculators. They meet all the requirements. Their input instructions are slightly different, but the outputs are very, very similar. So, there are strengths and weaknesses of both. If you were to ask me which was better, basically whichever one I'd been using the previous 10 minutes, I'd be saying was the better one. Basically, a student would not want to be going into the exam with a calculator that they had not used regularly in class beforehand. I'm just going to put a poll up on the screen for you, and if you'd like to let me know if you've got a preference at the moment, which might mean that I focus more on one rather than the other during this presentation. Right. Thank you. Okay, so from here it seems at the moment majority of people have already made a decision about focusing on the Casio. So when I talk through. All the examples using the Texas will be there, but I will talk a little bit more on the Casio. In terms of where to purchase the emulator, you can actually purchase it from the Casio website. You can get, and in fact, that's what I have on my desktop today, is a free 90-day trial straight from their website, and then you can purchase it from there. All right, so I'm going to look at some of the sample assessment material and hopefully go through how the calculators could be used in the exam. So an example of the iterative function, numerical methods is one of the topics where learners may be expected to use the iterative function on their calculator. H240 paper 1 question 9 focuses on numerical methods. In this question, part 1 requires learners to show their understanding of the mathematics behind Newton-Raphson, but then part 2 requires learners to show that they can apply Newton-Raphson, and they've got the formula there, so it's just the efficient use of their calculator in order to obtain a numerical result. Now, the key thing when using the iterative function, the answer recall button on the calculator, is to remember to put in your starting point first and press equals before putting in the formula. So this is the image for the Texas. So having put in the -3 and equals, then it's a case of putting in the formula, replacing X with answer, and then just pressing equals to get each of the values required. And here is the display for the Casio. One of the extra features that the Casio has is that you can actually specify the input format and the output format. So going into the setup, selecting input output, and then selecting having the maths input, so that's in the natural showing the fraction line, but having a decimal output, so option 2, which means you'll go straight to a decimal answer in the format that you're going to want for the answers for the question. And again, the key thing, putting in the -3, your start point first, and pressing equals so that you've got that original answer to go into the formula. There are other ways that it can be done on scientific or graphical calculators using the table function, and one of the things that the Texas has is that you can actually put in single values in the table function. So having started with -3 and got the answer, you can then type that in and it will automatically give you your next value. So as I say, there are strengths and weaknesses for both calculators, and being familiar with how your specific calculator works is a useful, will make sure that the students are well prepared going into the exam. So one of the key things in this reform is not having the statistical tables, and depending on which specification you're currently teaching, the fact that hypothesis testing is often not in S1, the MEI spec at the moment, I think, is the only specification that does have hypothesis testing. It has binomial hypothesis testing in S1, but the OCR spec A in the legacy did not have that. Now, what we've actually seen is that those students that have had to use the distributions have started using their calculators already, even though they could use the tables. Going into the reform, they have to use their calculator. And as I said, at AS, it is just the binomial and binomial and normal in the A level. So here's a example on the AS 230 paper 1, question 12, where we've got a binomial distribution and binomial hypothesis tests. So looking first at the mark scheme, because we're going to get the value for the statistical cumulative probability from the calculator, the marks are very much focused on setting up the problem, setting up the model, the null and the alternate hypothesis, and then using the value that you've obtained from the calculator to interpret that in terms of whether there is sufficient evidence to reject the null hypothesis and bringing everything back into the context. So the Texas has all the functionality, but here on the Casio, choosing option 7 from the main menu, scrolling down to the binomial cumulative distribution, and we want to find just a single variable, so option 2, and then putting in the values. So we're going to be looking for the fact that we can find 50 or less out of N 450 with the probability 0.097. And then taking it back into the context of the question, where in fact we want the probability of X greater or equal to 51, so 1 minus that value, and then comparing the 13.8% with 10%, so that we can then interpret that result and show that there is not enough evidence to reject the null hypothesis. Moving into further maths in matrices, and learners will be required to carry out the basic manipulation of matrices. It's quite straightforward for the paper writers to negate any advantage of the calculator and to test the basic matrix skills by including either algebraic variables, or if you've seen our spec, if we have specific command words in the question, the key one being, in this question you must show detailed reasoning, which indicates that just writing an answer would not be sufficient. That does not mean that students couldn't be checking their work throughout their answer using their calculator, but they would need to show where the values have been obtained. So in this question, parts 1 and part 2, they are fairly straightforward calculations which can be done with their calculator, but it's the interpretation that will ensure that students are demonstrating their understanding and gaining them the full credit. Part 3, there is a variable in there, so students will then have to show that they are able to do the multiplication themselves. But actually in this question, the cubic equation that has been formed, well, there's no reason why that part couldn't be solved using the equation solver, but again, bringing the values obtained on the calculator back into the context of the question. Using the calculators for solving matrix problems, the key thing is defining the matrix and putting in the values first before actually doing any mathematical calculations. So on the Texas and similarly on the Casio, choosing the matrix option, defining the matrix. In the Casio, you have to go through various screens of defining the column and then the rows. And then once you've defined each of your matrices, then you can go into the matrix calculations and you can work out, you can then choose matrix A times matrix B in this case, and then you get the results. And similarly in part 2, you could either work out the inverse. In the Texas, there is a specific inverse function. On the Casio, it's just using the power -1 standard key. Yes, there's a question about what an E-mark is. When I come to the next mark scheme, I'll make a bit more explanation on that. But essentially, the E-mark is for explanations. If you see B marks, that's for basically statements. The M marks are method marks, and then the A marks are accuracy. Where there are questions where students have been directed that they must show detailed reasoning, those method mark work must be shown. But for other questions, if it's just calculate, find, then the method marks could be implied by the accuracy being right. The standard advice to students about showing working in order to be able to pick up partial credit still applies. There's always the risk when a student does just type things straight into the calculator, that they might type something in incorrectly, and then if there's no working, then they're not going to get any marks. As I said in part 3, using the polymer solver, because it's a cubic equation, then it is a stored formula for both quadratic and cubic, so you will get all the exact results if there are solutions. The more general equation solver actually uses Newton-Raphson, so it does not give exact answers. There's a question about how to actually save it. If I go to my desktop, let's actually Tony, you're having a request to annotate. If I decline this just at the moment, and then possibly at the end, we can come back to that. So in the emulator, if you go into the menu, oops, just going to clear that. Matrix. It's always a problem trying to demonstrate online. My apologies for this. Yeah. Selecting 4. So having defined, so if I want a 2 by 2 matrix, if I just put 2 equals 1 equals 1 equals 2. After equals, once that's in, then you can just clear, and then to define another matrix, then you use the option button. If I want to put in, to check that's there, you can see it is there. If I clear option, define, now I can define a second matrix, a 2 by 2, 5, 1, 5, 1 equals. Once you've pressed equals and it's in, you can clear option, matrix A plus option matrix B equals, and then you've got the answer. Does that answer your question, Betty? Right, thank you. And solving the equation, again, on the Casio, choosing option A, the equation functions, and a polynomial, and the Casio does have up to order 4. The calculators will actually solve vector problems as well. To be honest, the amount of effort the students have to go into in order to get to define the vectors before doing the calculations, I'd actually think it actually takes longer to use the calculator than it does any of benefits in the exam, but they can be done. The two calculators are slightly different. The Texas, again, you have to define the vector. The Texas actually puts the vector in rows, so it looks like the 3i, the minus 4j, the plus 2k. Having defined all your vectors, then you can do the calculations. One issue is that the calculator will give it in a decimal form, so that's one way that we can write questions when we've given an exact answer. There's another reason why sometimes it's not a big advantage to use the calculator. The Casio is very similar. Whilst the Texas has a specific function, I should have said, for finding magnitudes, the Casio does have it. They have an absolute value function, so that can be used in order to find the magnitude. But again, it's as a decimal, not as a third. As well as the minimum requirements, all of these new calculators do have calculus solving functions, both differentiation and integration, but they are numerical solvers, so they will not give exact answers. So where questions have asked for an exact answer, then it is one way for a student in the exam just to check their answer, but it won't gain them the full credit. And again, we can ask questions such as here on the AS paper, paper 1, question 5, part 1 and part 2A, where students have to actually do the written working. But in part 2B, this is a question that can be done using the calculator, but you'll notice we've specifically chosen a region of the curve that crosses the axes. Now, if they spot this and put into their calculator working out the area above the axes between the limits 1 and 2 and subtracting what is the negative area between the limits of 2 and 5, if they just type that straight into their calculator with no working written down and got the answer, they would get full marks. But there is the risk that if they did that, if they type in something slightly wrong, or if they forgot about the putting a negative, then they might make a mistake and they would risk not getting anything if there was no written working shown. So showing the method they're going to use, and then either working out the two parts separately and just using the calculator or mentally finding out the area, is probably a safer method in order to be sure of the full marks. You'll notice we have a special case 1 mark. If they did just put in one integration between the limits 1 and 5, because they are demonstrating that they know that the calculator, well, they knew that they had to do integration, but they don't get the full marks because they haven't shown that they understand all the theory behind the process. And the question, if you did not use a calculator for these, you would still get the marks. But it should be stressed that the use of technology should permeate the teaching and learning, and so hence the assessment. So whilst you wouldn't lose marks, you might be penalised time-wise, having to do the extra work. Other functions that you would have on the calculator, the equation solvers. One of the ideas is the polymer solvers. Students have been tested on using the quadratic formula. So rather than testing them on GCSE knowledge, leaving that cranking the handle to the calculator so that there is more emphasis on the interpretation of the results. So the formulas in the calculator for quadratic and cubic, so you will get exact answers. The equation solver, as I mentioned, uses Newton-Raphson, so it will find single results provided you use a sensible start point. But it won't give an exact answer, so useful for checking answers. And then there's also the facility of solving simultaneous equations. So again, there will be less marks for the skills that they have demonstrated their strengths at GCSE, and bringing those answers back into the context of the question. And also, before using the solve functions, it's often you need to rearrange the equations into the right format that the calculator will recognize. So that's one way that we can make sure that students are showing full mathematical understanding. So that's a look at the applications in the exam, but technology is supposed to permeate through the whole course. So there are lots of examples of where you can use technology in the classroom to help ensure that you've got well-prepared students. So one of the big changes is the idea of the large data set. Now, for both the OCR and the MEI specifications, we have published the large data set as Excel files, so they can be manipulated in Excel, or the data can be transferred readily into any other statistical software, Geogebra, Autograph, or very specific statistical software. So I'm just going to just demonstrate one little thing that I got shown recently. So if I take some of the data from the OCR Spec A, the travel to work data, and all I've done is added a slide, a tab at the end, and I've taken some travel to work data for walking and cycling from 2011, and I've worked out the percentage of the total population. So I can draw a scatter diagram to see if there's any links between walking to work and cycling to work. But I've actually added a third column with a weighting. And then here I've produced, it's not just a scatter diagram, but it's actually a bubble scatter diagram. And I've actually added in a scroll button, And what I've done, I change that to 1. So County Durham now, with a weighting of 25, is the bigger dot. So I can, by scrolling through the data, changing which individual data point has that increased weighting, I can see where it goes. So because I've looked at this before, strangely enough, we've got quite a big outlier is Cambridge. And we can spot a specific point that we're interested in, or we can just scroll through and just see where individual points are. So that's one way that you could very simply make use of technology to help investigate specific bits on a large data set. Another good resource is Geogebra. There are plenty of resources that have been yes, so I should have stressed that bubble graph is one of the graph options in Excel. I'll show you where that is. Go into change graph types. So it could just be a straightforward scatter graph, but towards the bottom there is the bubble. So Geogebra has lots of demonstrations. It's a free to download resource, and there is lots of demonstrations that have been put on the internet that you can access. And you can if you sign up and have your own account, you can create your own lesson books, and you can tag useful resources. One of the things that we will be doing as we produce delivery guides and teaching ideas is we will be looking through resources from places like Geogebra to highlight them, so that we're doing some of that trawling through for you to save you a bit of time. As I say, Newton-Raphson is one of the classic things for using technology. The current C3 in the MEI spec has a bit of numerical methods coursework, as does their specific further maths numerical methods unit, and they will make good resources to use in class, even though there isn't coursework in the new reformed qualifications. Mechanics is a good area for using virtual investigations where it's not possible to, if you haven't got time or the resources to actually do mechanics experiments in class, it is possible. There are plenty of demonstrations that you can access in Geogebra. So again, so here got for further mechanics, we can run a simulation of two objects colliding. or we can have a particle that's been projected up a slope and then sliding down. Oh, my apologies. When I was changing through the slides, I managed to turn off my microphone. I do apologise for that. So I was just saying, Geogebra has many examples for mechanics, for matrices, for graph families of curves. So there's a lot of areas where you can either demonstrate in class or get students to do their own investigations during their independent learning. Now, I do apologise for the slight technical glitch towards the end, but everything has been recorded, and if you want to find out more, we have been running a number of webinars, which if you weren't able to attend the ones that have already occurred, then they will be available to download the recordings. We've got the conference on Friday at the Emirates, and then we're also planning some Get Started CPD full-day events, travelling around the country, where you can sign up for on the CPD Hub. If you're planning to teach OCR, if you sign up with OCR, and then you'll get regular updates when we've got new resources available, and any new information to help with your planning and delivery and future events. We are planning some network events, which are normally twilight sessions where one of the subject advisors will come out and play a part in your sort of networking events, either focused on a specific part of either A-level or GCSE, or a specific topic. We've done some twilight sessions on just general problem solving. If you would be interested in hosting a network event this term or next term or moving forward, then we're always looking for centres that would like to host events. So I hope this has been useful. Moving forward, if you'd like to download the specification and find all the details on the A-level maths at ocr.org.uk/A-level maths. You can sign up for the various CPD events, including signing up and getting the recordings of things like the webinars, or if you've got specific questions, if you contact OCR, then one of the maths subject advisors will get back to you either by telephone or by email, and you can follow us on Twitter. I look forward to talking to you in the near future. If there are any final questions, is it possible for a student to print out their screen from the ClassWiz Casio? It's not in the exam. The exams are written exams, and connecting calculators up to printers is not permitted by the JCQ rules. Unfortunately, I wouldn't be able to tell you how much the emulator costs, but if you do go on the Casio website, let's see if I can. One-year license offer. You will be able to get information on costs. Right. I think that's all I have time for tonight. I know that there is another webinar just about to begin. Stephen Keane from Science Studio, and actually he will have information on the costs, because he deals with selling all the different types of calculator that are available. If there are no other questions at the moment, then I will pass you back to our host, and I look forward to talking to you again in the near future. Okay, all right, good night.
You are now the presenter. You're the presenter. Oh, microphone's on. I'm gonna. Could you say which one? Oh, I'm the presenter. How do you say that?
Thank you for joining us on this live online event. We hope you found the session useful. A full recording will be emailed to you tomorrow. If you have any feedback, please complete the short survey that will appear when you have logged out. We will now be ending this session. Thanks again.